Second section in chapter 7 is about solving linear systems by substitution. So just like when we graphed and found the intersection point, this is just going to be algebraically. So our steps are to solve one equation, there's always going to be two, for one of the variables. There's always x and y, it doesn't matter which one you solve for. One variable. Number two, you're going to substitute that equation that you just solved into the other one. And lastly, you are going to solve that, the number two, you're going to substitute. And the last thing you're going to do is get that solution. You're going to substitute your solution into the first one to get the second answer. Okay, so the first thing you're doing is trying to solve one of the equations for one of the variables. Luckily on this one, the top one is already solved for y. So all that you're going to do now then is take the 3x plus 2 and substitute it into the y spot. So x plus 2 times 3x plus 2 equals 11. So now you only have x's to deal with in this equation. We do, however, have to do the distributive property with the 2. 6x plus 4. Then you're going to combine like terms. We have 7x plus 4 equals 11. You will subtract the 4 from both sides and get x equals 1. You're going to take that 1 and put it back into the equation that was solved for the other variable to find out what the other variable is. So y equals 3 times 1 plus 2. Y equals 5. Then you're going to write your answer like a coordinate point. 1, 5. That's it right there. So I think this system is a little bit more systematic than the other one, which is a little bit easier, I think. Okay, so we need to solve one of these two equations for one of the variables. It looks like the top equation is going to be the easiest to solve for x, so that's what we're going to do. X equals 2y minus 6, and then you're going to take that and plug it into the x spot of the other equation. 4 times 2y minus 6 plus 6y equals 4. Need to distribute. 8y minus 24 plus 6y equals 4. 14y minus 24 equals 4. 14y equals 28. Y equals 2. And then we're going to take that 2 and plug it into the y for the equation that we just solved for x. Which is negative 2. So if you were to graph these two equations, they would intersect at the point negative 2, 2. However, I think this is a little bit easier than solving it that way. Okay, we're going to do the same thing on these three. Top's already solved for y, so you're going to plug that into the y spot in the bottom equation. Combine like terms. And we get x equals 1. Then we're going to take that and plug it into the x spot on the equation that's solved for y. We get y equals 7. Okay, top one I think we could solve for x. Might be a little bit easier. Just add the y across. Plug that in for the x. And then plug that into the equation that was solved for x. This is where the distributing, you have to be really careful. am going fairly fast, but you can pause at any time to relook at something that I'm doing. Okay, now we're to the last page, which is the word problems. So many businesses may pay website hosting companies to store and maintain the computer files that make up their websites. It looks like the internet service provider charges a setup fee of $10, but then it's $21.95 a month, and the website hosting company does not charge a setup fee, and it's $22.45 a month. What we're trying to do is find the number of months after which the total cost is the same. So we'll have two different equations here. The first one for the internet service provider. Our equation is y equals 10 plus 21.95x, because it's 21.95 per month. And then the website hosting company is just 22.45x. So if I want to know when they are equal, I just set them equal to each other. And since they're both equal to y, this is a method of substitution. 22.45x equals 10 plus 21.95x. Subtract the 21.95x from both sides, and we get 0.5x equals 10. X equals 20, and that's in months. This next one is a little tricky. For extremely cold temperatures, an automobile manufacturer recommends that a 70% antifreeze and 30% water mix be used in the cooling system of a car. How many quarts of pure antifreeze and 50% antifreeze and 50% water mix should be combined to make 11 quarts of 70% antifreeze and 30% water mix? So our two different variables are going to represent something. The first one is going to represent the 100% antifreeze, and y is going to represent 50-50 for water antifreeze. So this is going to be pretty similar to the first section, where we had one of our equations is just x plus y equals 11, because we're not sure how many of each we need. And then the other one's going to, instead of cost this time though, our other equation is going to include the percents. So our other equation is going to be 100% x, so that's just 1x, plus 50% y equals 70% times 11. So we're really just taking into account the antifreeze on these percentages. So this is x plus 0.5, y equals 7.7. So I'm going to probably solve the top one for x. Put that in the bottom. So 7.7 minus 11 is negative 3.3. And negative 3.3 divided by negative 0.5 is 6.6. So we're going to have 6.6 quarts of the 50-50 solution. And then we're going to put the 6.6 back in for the y up here to figure out how many 100% antifreeze quarts we need. Which is 4.4 quarts. And that was it for section 2 on using substitution to solve systems of equations.